Hi everyone, this is Chaitanya, and me and my team, Binary Brains, is presenting before you EcoPredict. So the theme for this hackathon which we have chosen is AI for climate change. So let us see further what our project serves under this specific theme. So let us move towards the problem statement of our project. So as we can see, there are a lot of challenges towards nature currently, and one of the most pressing global challenges is the climate change. And there are many other challenges like rising global temperature, then different uneven rainfalls, different shifting of rainfall patterns, and many other such problems going on. And there are many traditional climate prediction models also available, but they are often slow and they are very computationally heavy, so we cannot get it on time. It cannot be delivered in real time. So for that purpose, we thought to come up with this idea. Like usually due to this traditional methods, many farmers, like mentioned here also, like many farmers struggle with crop planning due to unpredictable rainfall. So nowadays we are experiencing very unpredictable rainfall, which is hampering the farmers in planning the crops. And then many city planners are also worried about the air quality index and all, and government also faces various difficulties in planning different disaster management or various policies and all. So our idea basically is to build AI-powered predictive climate modeling system, which uses advanced algorithms and which uses interactive visuals and graphics like graphs, charts, maps, and various dashboards. So which will be able to deliver the accurate results in real time, and which will be even easily understandable by the uh, farmers or local citizens like us, or city planners and government, everyone. So this is what we have planned. So let us see further about our project.
This slide outlines the core objectives of our EcoPredict project, which integrates artificial intelligence, big data, and climate science to deliver accurate and actionable environmental insights. Our goal is to enhance climate forecasting using advanced AI and ML models such as LSTMs, CNNs, and transformers to predict rainfall, temperature, air quality, and sea level changes with higher precision. To take these predictions accessible to all users, we present information through intuitive visuals like charts, graphs, and heat maps rather than raw data. We also aim to improve our user interaction through an AI powered chatbot. Additionally, the system provides early warnings for climate related disasters using clear visual indicators, supports farmers and citizens with crop and integration guidance and air quality awareness, and assists policymakers by offering trend analysis tools and long term climate projections for more informed planning.
So moving towards the proposed solution, our system is designed in the five main layers. First is a data collection layer. We use an open weather API key to get a real-time weather data like a temperature, humidity, and a rainfall along with the optional IoT sensor input. Second one is a data processing layer. We use a clean filters the and normalize the data. It's ready for analyze. Third one is an AI/ML engine uses a model like LSTM and CNN to predict the weather trends and detect the patterns such as the drought or storm. In the prediction and analytic layers, the system creates a visual line chart for the rainfall trends and bar graph for air quality heat maps. and user interface for the mobile web application. Display all of this on the web and dashboard with alerts and color coded risk prediction. Second one is in a workflow of our website. A climate prediction workflow starts with the collection real-time data through the Open Weather API, then process it into using an AI models for analysis, and the result turns into the visual forecast and show on the interactive dashboard with the alter for users. Thank you.
So hi everyone, this is Chaitanya. So our project EcoPredict basically is an idea to build an AI-powered predictive climate modeling system which uses advanced algorithms as well as interactive visualization features like charts, graphs, maps, and various dashboards. So it also delivers accurate results, real time results, and they are easy to understand to common citizens like all of us and to experts for further predictive measures. So let us see what are these features which we have implemented. So the first one is interactive climate dashboards. So in this we will be giving different visualization for uh, visualizing what is the current situation or what will be happening further, like real-time graphs for rainfall and temperature measures which have been taken there, then different predictive maps, then heat maps and all. This will come under this, and uh, then we will also there will also be a comparison between past and future trend. So based on that, we can take further actions for crop plantation and all. Yeah, so there are different modes also in our eco predict, that is agriculture mode. So as mentioned in the problem statement, also many farmers they lack this service because they don't have that much facility to analyze and all. So we bring here this EcoPredict, which has various features, and among this one is agriculture mode, where there are crop specific advisory dashboards where like a particular crop is this type, so for this season this much of irrigation is needed, this much of sowing is to be done, such type of soil uh, and climate suitability is needed. And then also the carbon and pollution tracker is also been embedded, and it is a very mobile friendly access, so even a farmer nowadays has a phone, so he can also access in his phone about these various trends for his particular region. Moving on to the next slide, let us see. Yeah, so on this slide, let us see another features, like we have also an interactive AI assistant. Like if any farmer or if any expert wants to ask any query related to the trends or the prediction related to weather and climate, they can ask it there, and it resolves accordingly. Then there is also a what if analysis. This is also main part, that uh, we have different scenarios calculated there, so that it allows user to uh, analyze and stimulate different scenarios and see the predictive impacts of temperature and rainfall hands before only, so that they can be prepared with whatever the situation will be coming. Then we have visual forecasting, we have automated daily reports and different visual insight.
So, hi everyone, myself Soham. I'm from Binary Twins. So, I'll be showing the final output of our project. So, this is the dashboard, incorporated, and there are some features in our website that are mentioned here. As soon as I click on the enter dashboard, it will show the actual temperature. This is the main dashboard of our website. It shows the real-time data that is fetched through original API. Okay. Currently, it's showing the actual climate, its temperature, and humidity of Pune, India. Okay. So, active alerts, moderate air quality, rising CO2 levels, maybe rainfall alert. Okay. So, it has the data of last 30 days. Based on that, it predicts the next 30 days. This is the rainfall data, the temperature data. This is the breakdown of the air quality. The nitrogen, amount of nitrogen dioxide, ozone layer, ozone, risk maps, interactive climate visualization. Absolutely. Will show the exact risk of weather, the climate trends. Uh, so these are the actual climate trends of last some months. These are the future predicted outcomes through the modern trend map. The current trend shows this is the simulator part where the user can simulate some outputs. This is the agriculture part where the farmers will get the actual data, that is the soil moisture, what is the sun exposure, then the irrigation advisory, crop sowing calendar, it will show the month in which the which should be sown, and best planting dates, fertilization now. Climate tracker, it will show the current atmospheric CO2 level. It shows 420 parts per minute. Industry, 35% of it is coming from the industry. And this is the CVT emission cost. Here is the graphical representation of this data. Manufacturing plants, vehicle emissions, contributors, sectors. This is the live data. So this is the chatbot of our website. We'll ask it what is the weather tomorrow in Pune. So the back in the backend, there are some API calls made to the backend, Django backend. This is done through the Gemini tool.